Hey everybody, guess what? It is 3.4 parallel lines and transversals. We're going to be talking about transversals with parallel lines this time. Okay, so we're going to be finding congruent angles formed when a transversal cuts parallel lines. Don't forget about what a transversal is. So please write this down and I will explain. It says the corresponding angles postulate. That says if two parallel lines are cut by a transversal, then the corresponding angles are congruent. So we talked about in 3.3 what a corresponding angles are. Remember, we have two parallel lines, and we can tell they are parallel by those beautiful arrowheads there, and we have another transversal coming down. Corresponding angles being angle here and an angle here, those two, because those lines are parallel and the transversal cuts them both, those are now congruent. So all corresponding angles would be congruent. That's also true for alternate interior angles. Okay, this is where if two parallel lines are cut by the transversal, the exact same situation, then alternate interior angles are congruent. So corresponding angles are congruent if you have two parallel lines with a transversal. Same thing with alternate interior, which then leads into alternate exterior angles theorem as well. Same two parallel lines, same transversal. That just tells me that the alternate exterior angles are now congruent as well. The only different one is going to be the last theorem that we're going to talk about today, and that's the same side interior. If they are same side interior angles, we have two parallel lines cut by a transversal, then those same side interior angles are supplementary. What does it mean to be supplementary? That's when we're talking about two angles that add up to equal 180. Okay? So again, same side interior. If you remember from 3.3, we have two angles this time, two lines. This time they're parallel with a transversal cutting in between them. Now that tells me that same side interior angles, this angle and this angle, same side of the transversal on the interior of our two parallel lines, those would add up to equal 180. Two supplementary angles. All right, moving on. So we're going to try a couple of angles here. Now, remember our theorems that we've talked about. This tells me, looking at this graph, letter A, we're looking for the measure of ECF. So we're looking for ECF. Okay, now, we know, based on our arrowheads here, those red arrowheads, that AG and DF are parallel. So what that tells me is, number one, my corresponding angles are congruent. Number two, my alternate interior angles are congruent. Number three, my alternate exterior angles are congruent. And what do we know about our same side interior? They are supplementary. They add up to equal 180. So ECF, we're looking at this angle right here, which means the corresponding to that angle is going to be BCG right here. BCG. So we know that those are two corresponding angles, which means ECF is equal to 70 degrees. We know that is 70 degrees because they are corresponding angles. All right, moving on. Next one, we're going to check this one out. We are going to be looking for DCE. So we are looking for this angle of DCE. Now, it tells us right here that DCE is 5x. However, we can't figure out the measure without finding out what 5x is. Okay, so the very first thing is we need to set up an equation. Remember, these two lines, AB and DC, are parallel. Okay, so what does that tell me about corresponding angles? They're equal. Okay, they are equal. So that means in this equation, because we know they are equal, because we know that they are congruent, we set them equal to each other. 4x plus 22 is equal to 5x. 4x plus 22 equals 5x. We set up an equation because we know that AB is congruent to DC, is parallel to DC, because we know that those two corresponding angles have to be congruent. Okay, when we set it up, we bring this 4x across to the other side because we want x's with x's, numbers with numbers. X is equal to 22. However, we're looking for DCE. We just found x. We're not done yet. Ask yourself, when you get to the bottom, when you find x, ask yourself, am I done? Am I done? Am I done? No, we're not done yet. Okay? We need to take now this 22 and plug it in for our DCE. So we need to take 5 times 22. All right? So if you take 5 times 22, what do you come up with? What is it? Absolutely 110 degrees. Excellent, excellent, excellent. Okay, let's try another one. Same idea. Now we're here looking for EDG and BDG. Same idea though. Use the exact same information because we have two lines that are parallel with a transversal, that transversal of FE cutting right through there. Okay? So find EDG, find BDG. All right, EDG. We're looking for EDG. That is this angle right here. It tells me that EDG is x minus 30. Okay? X minus 30. We know that this is x minus 30. Okay, so EDG is x minus 30. Now we're looking for the opposite, not opposite. We're looking for an angle that we know. There's two ways we can figure this out. We could set an equation equal to 2x minus 135. If we do that, we're going to bring our x's over together, minus x. So we have negative 30 is equal to x minus 135. Add 135 to each side. X is equal to 105. Okay, when we do that, we would need to then plug it back into x minus 30, which makes it 105 minus 30 to make it 75 degrees. However, we could go through all that work, which is excellent, perfect work, but we also know up here that it's 75, because what type of angles are those? Yep, you got it. Those are alternate exterior angles. Alternate exterior. So now we have alternate exterior and corresponding. You can get it two different ways, but it doesn't matter. They both come up with the exact same thing. EDG is equal to 75 degrees. Excellent. So moving on to BDG. Now we have BDG. We're trying to find a new angle. Again, same exact situation. Two parallel lines, transversal, BDG. BDG. Here we have this information of x, and we have the other information that we can use is going to be this 2x minus 135. So what do we do with those two equations? Well, we know that they are same side interior angles. What happens when they're same side interior angles? We have two parallel lines with a transversal. All of that combined, we can do 2x minus 135 plus x to equal 180. Remember, these are supplementary angles. Supplementary angles. Okay? When we add all of these, we get 3x minus 135 is equal to 180. We're going to add 135 to each side. And when we do that, we get 3x is equal to 315. Okay, we now need to solve for x. Divide by 3 on each side. And when we do so, we get x is equal to 105. X is now equal to 105. We plug that into what we need to know for BDG, which is x. So What is BDG? 105 degrees. Excellent. Excellent, excellent, excellent. Last note of the day, now we are going to be finding ABD. So we're going to be finding this angle right here. I know this looks a little confusing, but that 2x plus 10 is ABD, and this 3x minus 15 is going to be BDE. So I want you to set up an equation and solve. Think to yourself, am I done? Am I done? Give her a shot. All right, so we need to set up an equation. How do we set up an equation? What type of angles are ABD and BDE? We use these two angles because that's the information we know. So when we set up an equation, we are going to set them equal to each other. Why can we set them equal? Because they are corresponding angles. So we have 2x plus 10 is equal to 3x minus 15. Now it turns into a simple algebraic equation. Get x's with x's, numbers with numbers. I'm going to bring my 2x to one side to get 10 is equal to x minus 15. Bring my 15 to the other because we want numbers with numbers, x's with x's. And 25 is equal to x. This is where we stop. Stop, think back. What are we actually getting for an answer? Are we done? And the answer is no. We're not done. Why? Because we just found x. But that wasn't the question. The question was find ABD. So let's find ABD. We need to plug x back into the equation. So plug that x back into the equation. You get 2 times 25 plus 10. 2 times 25 is 50 plus 10 is 60. Don't forget your degree symbol. There's a big degree symbol. Big and ugly. Degrees. Gosh, don't you just love math? Don't you just love parallel lines and transversals? I'm glad to see the excitement. Woohoo! All right, we are done for the day. I know you're sad. I know you're bummed. There's no more notes for today. But don't worry. We'll get 3.5 later. Have a good day.